Hey guys, it's Mrs. Diaz. I want to go over some of the topics from Unit 4A. I want to do a little review because we have our final coming up. So let's take a look at some of our homework assignments from 4A. Right now I have homework 4.2.1A open, and this is all about the unit circle. So we got to go back and remember the unit circle. In fact, I'm just going to pull up unit circle on Google here, and there are like a million to choose from, but let's just choose, it doesn't matter. There we go. Here's our unit circle. You have to have this memorized, so you cannot have this just on the next tab over for your final, okay? So please, please, please make sure you memorize this and you have this memorized. So after having that unit circle memorized, then we're simply gonna figure out what cosine is, what sine is, all that good stuff. So let's refresh our memory. Cosine, remember, cosine is going to be our x-coordinate. So cosine is our x-coordinate, and then sine is going to be our y-coordinate. So cosine is x, sine is y. If we want to do tangent, well, tangent is y over x, or sine over cosine. Okay. We also learned a phrase at the beginning of the semester where it was chosha cow. So if you remember chosha cow, chosha cow, those are the reciprocals of the original three trig functions. So the C is for cosecant, and cosecant is the reciprocal of sine, which is hypotenuse over opposite. And then we have secant, which is the reciprocal of cosine, which is hypotenuse over adjacent. And then last but not least, we have cotangent. Cotangent is the reciprocal of tangent, which is adjacent over opposite. Okay, so remember we talked about right triangles. We're going to look at right triangles, but if we're not talking about triangles that are not on the unit circle, so basically right now you want to think about the unit circle. So cosine at pi over 3, well, what you'll do is you're going to go to pi over 3. So pi over 3 is here in the first quadrant, and figure out the x-coordinate. So the x-coordinate is 1/2. So go back here, and cosine of pi over 3 is 1/2. Okay? There's a lot of examples here in this homework. I'm not going to do all of them, but if we did sine of pi over 2, well, remember sine is the y-coordinate. So if you go to pi over 2 on the unit circle, that coordinate is 0, 1, so the y-coordinate is 1. Let's do a tangent, because those are a little more work. Tangent of pi over 4, if you remember on the unit circle, pi over 4 is right in the middle. The coordinate is root 2 over 2, comma root 2 over 2. And tangent is y over x, so root 2 over 2 divided by root 2 over 2 is going to give us nice clean 1. Let's do something more challenging like secant. Secant of pi over 6. So again, on the unit circle, pi over 6 is that first point here. The coordinate is root 3 over 2, comma 1/2. Secant, that's the reciprocal of cosine. So it's 1 over cosine, which is 1 over x. Here's the x-coordinate. 1 over root 3 over 2 is the same thing as multiplying by the reciprocal, 2 over root 3. So we have 2 over root 3, but we can't leave a radical in the denominator, so multiply top and bottom by root 3 over root 3 is 2 root 3 over 3. So this answer here is 2 root 3 over 3. Okay? Again, there's so many examples here. I'm not going to go through all of them, but you do need to remember your unit circle, and you need to remember the reciprocal functions. So chosha cow. Let's look at one more, like 0. So cotangent of 0, well 0 is right here on the unit circle, and that coordinate is 1, 0. Cotangent is adjacent over opposite, so it's x over y. So it's 1 over 0, which is actually undefined because you cannot divide by 0. So anytime you divide by 0, it's undefined. So those are some examples. We're going back to the unit circle days. I want to look at another page here. And actually, let's look at this one, 4.2.0, talking about angles. So there's another formula that we learned back in the day. It was converting from angles in degrees to radians, and then vice versa, radians to degrees. So remember, you have to remember this formula. Multiply by pi over 180. This is if you're going from degrees to radians. Okay, if you're going the other way from radians to degrees, well, then you're just going to take the reciprocal of that formula, which is 180 over pi. Okay, and we're doing this without the calculator. So look at number 3, convert the angle 180 degrees to radians. So we're going to multiply by pi over 180. The 180s cancel, and we're left with pi. And you know that at 180 degrees, that's the same thing as saying pi radians. The next one is 30 degrees. So 30 degrees times pi over 180. Again, 30 degrees is on the unit circle, so we know that at 30 degrees, it should be pi over 6. And it's true because 3 goes into 18 6 times, so pi over 6. And we're going from degrees to radians. Let's go radians to degrees. So we have 5 pi over 6, and we're going to multiply by 180 over pi. So remember to take the reciprocal. The pi's cancel, that's what we like to see. We know 180 divided by 6, well, that was the 30. So 5 times 30 gives us 150 degrees. And 5 pi over 6 again is on the unit circle. It's in the second quadrant, and it's at 150 degrees. 11 pi over 6, that's also in the unit circle. 11 pi over 6 is in the fourth quadrant, and that should actually be 330 degrees. Some of these, like if you know your unit circle, then you know what the angle is, but if you don't know, use these special formulas. Okay, those are our special formulas. Let's see what else is on this page. I think it's just converting. You're going to see some angles that are not on the unit circle, like 255 or negative 276. Okay. Let's see. But if you do any of these, we're still using the same formula. I want to actually talk about coterminal. So remember, coterminal means it's an angle that lands in the same spot. So it says find the angle between 0 and 360 if it's coterminal with 685 degrees. So first of all, 685 is really big. It's bigger than 360. So what we're going to do is we're going to do 685 minus 360, because what we're doing is we're doing a full circle. 360 is a full circle. So subtract a full circle. That's going to give us 325 degrees. So 325 degrees is between 0 and 360, and that means it's coterminal to 685 because it's going to land in the same spot. Here's another angle that's larger than 360, so we're just going to subtract a 360. That's going to get us, that's going to turn into 15 minus 6, which is 9, and that's going to be 91 degrees. Okay, these ones, if you remember, we did this one in class. That's a very large number, negative 1,746. Basically, we're going to add 360 as many times as we need to get a number that's between 0 and 360. So we have negative 1,746 degrees, and we're going to add a 360. You know what, I'm just going to pull out my calculator because that's a really large number, and I don't think it'll be that big on our test. So we got negative 1,746 plus 360 gives us negative 1,386. Again, we're going to add a 360 plus 360. It's going to give us negative 1,026. Again, plus 360. 1,026 plus 360. And that's going to give us negative 666 plus 360. Negative 306, close, plus 360, 54. So finally, I kept adding 360 until I got an angle between 0 and 360. So that's what you're doing with these. If you are given an angle in radians, well, think about what a full circle is in radians, and that's 2 pi radians. So 26 pi over 9, we're actually, since it's a positive, we're going to subtract a full circle, which is 2 pi over 1. Remember, whenever you add fractions or subtract fractions, you need a common denominator. So this is going to be 18 over 9, because I multiplied top and bottom by 9. So 26 minus 18 should be 8 pi over 9. And that's our coterminal angle. All right, I'm going to go ahead and stop right there. I'll take a look at the next few homeworks using, right now we are focused on 4A. Remember that the final is 4A, 4B, and Unit 5. So I will talk to you guys soon.